Hey everybody, welcome to night 3 of Lambda School's Web Dev 101. My name is Deandra Ryan Moss. I'm your instructor. I am in a strange kitchen in Seattle right now, and there is a giant stack of croutons behind me. So I think it's the perfect time for us to learn some JavaScript. So that's what we're doing tonight. Before I get into that, let me talk to you a little bit about Lambda School. So as you guys probably know by now, Lambda School is a super cool program where you can learn how to program online for free, at least for free to start. So Lambda School is a completely online web development immersive. So it's a 6-month program with a new course starting every month. We do have a part-time course starting next month as well. So that is a year-long course that runs in the evenings. So that's Lambda School for you. It will teach you how to do all sorts of cool things. I want to talk in a little bit more detail about what the curriculum of the main Lambda School web development course entails. So now that you guys have a little bit of bearings about web development and what is involved in that, I want to talk to you about what we actually teach you guys in the main curriculum of Lambda School. So as you might imagine, we do full stack web development. That means front end web development and back end. So on the front end, we're going to be looking in detail at all these languages that we're exploring in this mini bootcamp. That means HTML, CSS, and JavaScript. And not only are we learning those languages, but we're also learning several frameworks that go on top. So we'll be exploring CSS preprocessors, CSS frameworks, Bootstrap specifically, and looking at a JavaScript framework called React. So you'll be learning the base languages in a lot more detail, as well as these super useful frameworks that go on top. And then beyond front end, we also explore back end. So using JavaScript, we also will learn how to build the back end of a website. So that's going to involve data retrieval. You'll also do some database work there. Really fun stuff. Personally, my favorite. So who knows why I'm here teaching front end stuff. But no, front end's cool too, but I love back end. So you guys should be super excited about that in the main curriculum. And then beyond just teaching you all these awesome practical skills, we also teach you some more computer science-y, academic-y skills as well. So we explore Python, which you can also use to build a backend. I personally have mostly used Python to do data projects. So Python is great for machine learning and data processing and all that. And then we learn C, which is a object-oriented language. And with that, we explore algorithms. So it's a really cool, well-rounded education because you're learning some very hands-on skills, and then you're learning some of the more background computer science-y type stuff you might learn in a university class. So you get the best of both worlds. So that is everything that you will learn in 6 months at Lambda School once you enroll in the main curriculum. If you are interested in getting the ball rolling on that, please reach out to Karen Zachary in Slack. And as a reminder, you do not have to pay anything upfront. It is a de-risked tuition model, which means that you can pay $0 to start, and it's only after you are hired that you pay us your tuition. So you can slowly pay us back for the school over the first 2 years in the job. So once again, reach out to Karen Zachary with any other questions or to start the admissions process. So in Web Dev 101, this 2-week mini bootcamp, we're going to be just taking a fundamental look at some of these topics from the main Lambda curriculum. So we've already seen HTML and CSS the last 2 nights. Tonight is all about JavaScript. So we are going to start with the basics of JavaScript. And JavaScript is super exciting because it's the first programming language that we are going to explore. So as a reminder, HTML and CSS are both markup languages, which means they're designed to display content, whereas a programming language like JavaScript is actually a bit more versatile. So in programming languages, we get to play with all sorts of logic, and the limitations of what we can do with JavaScript are pretty much endless. As we know, it's a big puzzle piece in the whole web development puzzle, but there's also a lot of cool stuff we can do. So we'll talk about how JavaScript fits into web development, but honestly, a lot of what we're going to do in the rest of this bootcamp just involves solving little problems and doing little scripts in JavaScript, just so you guys can get the fundamentals down. So we won't be doing much web development for the rest of the course, but we'll be laying some pretty critical foundation so that you guys are ready to jump into the web development side of JavaScript once you get into the main curriculum. So that's what we have in store for us tonight and for the rest of the course. So as a reminder, We're going to be doing JavaScript tonight, tomorrow night. Then you guys have a 3-day weekend. And then we'll start again next Monday, do 4 more nights, and that is it. So that's what we're up to here with JavaScript for the rest of the course. Let me share my screen, and we'll do a little bit of a review of how JavaScript fits into web development, and then I'll start teaching you the basics of how to actually use and write JavaScript. So here we go. Let me share my screen. Okay, so up here I have this sample web page that we have been playing with for the last 3 nights. So let me pull back up that code base that we've seen a couple times now, and we're just going to review one more time how the JavaScript fits into this puzzle. So as a brief review, we know that HTML actually puts the content on the page. Here's our HTML file. We know that CSS styles the page. And then now we're going to play with the JavaScript. So just by looking at this page here, we can see some unfamiliar stuff. We see a couple unfamiliar keywords and definitely some unfamiliar syntax. So we're going to be unpacking a lot of what's going on here over the next week and a half. So by the end of next week, what probably looks like a bunch of crazy nonsense is going to actually start to make sense. But for now, we can talk about what's going on a conceptual level. So as I've showed you guys twice now, the JavaScript is the piece where we make our website functional. So when I press this button, bam, some words appear. So let's talk a little bit more detailed about what's going on in this JavaScript. The JavaScript is really cool because it actually interacts with the CSS and the HTML, and it can change what is going on with the CSS and the HTML dynamically. So you could think of these 2 files as being the starting place for the web page. This HTML page says what is on the website to start. The CSS page says how does it look to start. But once we throw in JavaScript, it's open season. We can start to change our CSS and our JavaScript as we go. So what this is doing is we actually grab our button. So we are grabbing our HTML element of a button and saving it somewhere. And then what we do is we add a listener. So basically we're saying, okay, web page, pay close attention. And if anyone clicks this button, I want you to execute some logic. And when the button is clicked, what we do is we find all the hidden spans on our page. So to start, we have these 4 hidden spans. So then we'll search, we'll find all the hidden spans, and we will actually change the CSS on all of them. And then I have this console log hello too. We can get rid of that for now, actually. So that is all of the logic. Once again, I don't expect you to understand on a deep syntactical level how that happens, but just get an idea of what JavaScript is capable of. It's capable of changing the HTML and CSS on the click of a button or on a hover or on any other event. But before we can do something cool like that, we have to learn the basics. So let me talk a little bit more about what JavaScript is like, and then we will start to do some actual JavaScript writing. So as I mentioned before, JavaScript is a programming language, which means that there's all sorts of fun logic built into it. We're actually executing step-by-step instructions versus, trying to render content with a markup language. So JavaScript is going to be more similar to languages like C or Java or even Python, which are all programming languages. One point of clarification is that Java and JavaScript are totally different languages. It's really confusing because they sound like they're almost the same thing, but they're just completely different languages with similar names. So just wanted to clear that up. But all these programming languages do have a lot of commonalities. So if you're coming from one of those languages I just listed or another object-oriented language, you'll probably recognize a lot of what I teach you, though the details and the syntax tend to be a little different from language to language. But that's good news, because once you learn one, it becomes a lot easier to learn more. So let's go ahead and do some JavaScript. As we've been talking about with these other 2 languages that we've explored, when you write languages, the first step is, where do I write it? And as per usual, we have a couple different places we could write. If we're trying to write something more complex, we probably want to use a code base or a text editor. But for this course, we'll be focusing on using a sandbox environment called Replit. So this is Replit. Hopefully you guys have all made accounts for it. You'll be using it for your homework from here on out. And of course, you're welcome to code along as we go. But I'll get into that in a second. I just want to show you one quick example of a script that I have written in my code base. So here's a little example of something cool you might be able to do with JavaScript. This is a little script that goes ahead and looks at a list of words, and then it prints out the longest one. So it checks all these words, figures out which one's the longest, and then logs it out. So if I'm actually writing JavaScript code like this in my computer, there's a couple different ways to run it. First of all, the browser is designed to read JavaScript. As we can see, this page here works. So somewhere behind the scenes, JavaScript is being read. Just like with CSS, we can link in JavaScript via our code base, and then it will run in the browser. But another way a common way to run JavaScript on our local machine is to actually use something called Node. So I don't want you to get too bogged down on what Node is, because it's a little more of an advanced topic and we won't go into it too much in this course. But Node is basically a tool that allows us to run JavaScript on our actual machine using the command line. Mostly, I'm just showing you this because I want an excuse to use the command line, because I love the command line. It's super fun. So this is more of a preview into some stuff you'll see in the main curriculum, which is that if I want to, I can, using Node, run this file. So as I mentioned, this file expects a list of words. So I'm just going to type a couple words here, and then I run this file, and it actually finds the longest word. And from this list, peach was the longest word. So that's pretty cool. Maybe a little bit of a side tangent, but I just wanted to give you an example of something cool we can do with JavaScript to get you guys excited, to show you the command line to get you excited about learning that in the main curriculum, and then just introduce you to Node. And for right now, you can think of Node as being the tool we use to run JavaScript locally on our machine. So those are two ways to run JavaScript. You can run it via the browser by linking it into your web page. You can run it locally using Node. And then finally, we can take the shortcut and just use Replit. And in Replit, we can press the run button and it will run whatever code we have written here. So those other two examples might be a more common way that you might run JavaScript out in the real world, but for this class, you don't have to worry about them because you'll be doing all of your homework in Replit. So just a reminder, Replit is a sandbox environment, which means it's kind of a mocked out little environment that's great for running short chunks of code. It's super good for teaching. It's great for some debugging that you might be doing on the job, but it's not exactly where we would be writing a big complex script or project or code base. So that is Replit. Make an account if you haven't already, and let's start to write some code. Okay, cool. So let's go ahead and create variables. This is the first thing we are going to do. So there are different data types in JavaScript. So there wasn't anything super analogous to this in the languages that we've seen so far. In HTML, for example, we create elements, which are things that are on the page. And but in JavaScript, we create something called, we create objects, basically. And they're different types of objects. So there are different things that we can create. Let me show you a few examples. So we can create numbers. For example, I just created a number. That was super easy. I just typed out a number and then followed it by a semicolon. And everything in JavaScript will be, almost everything in JavaScript will be followed by a semicolon. So the first object type is a number. And so numbers are really easy to create. We literally just type out numbers and we've created them. We can create negative numbers. We can create decimals. Those are numbers, very straightforward. So let me show you a couple other things that we can create in JavaScript. And as an aside, when I run this in Replit, whatever my last line of code resolves to will appear over here in green. So we'll be talking a little bit more about what that means as we get into more complex stuff. But you guys might have been wondering, what is this green thing that's popping up over here? That is the last line of code. So my line 2 is really simple right now. I've just created a number. So that's going to appear over here in green. So the next thing I want to show you is a string. So a string is a bit of text. So and it doesn't necessarily have to actually be, words. It could be a bunch of symbols. It could be nonsense. It could be a single letter. Excuse me. It could actually be a blank bit of text. It could be a number. But what is the difference between a number and a string? Well, on line 2, we have an actual number. And we can tell because we have not put it in any sort of quotes. So when you just type out a number, it is the data type of number. But when you put anything in quotes, including a number or just text like I showed you before, that is called a string. So you always know when you've created a string because it's in quotes. It can be in single quotes. It can be in double quotes. If you try to mismatch quotes, you will get an error, so don't do that. But that is the next thing that we can create using JavaScript, is a string. All right, the next thing I want to show you is called a Boolean. And I know I'm just kind of throwing things at you right now and not really showing you how or why you'll use them. So bear with me for a minute. Let's just learn these data types, and then we'll go on and play with some examples. And you'll start to get an idea tonight and definitely over the next few nights about in what context these different data types are useful. Okay, so Booleans. Booleans are super simple. There are 2 Boolean values I can create, true or false. So Booleans literally refer to this idea of something being on or off, true or false, 2 options. And Booleans are really important because they're kind of a little window into what's really going on at the computer level. As you might know, computers run on ones and zeros, or in an even more basic sense, they run on little electric circuits that are either on or off. So at the most basic computer level, everything is translated into this binary idea of something is on or off. In JavaScript, luckily, we have slightly more user-friendly things to work with than zeros and ones, but this Boolean data type kind of follows that same pattern of Booleans are either true or false. So as a reminder, if I typed out true in quotes, that's not a Boolean, that's a string. That is the word true. If I type out true not in quotes, that is a Boolean. That is the concept of true. So we so far have numbers, strings, and Booleans. The last 2 I want to show you are kind of weird. They're called null and undefined. And so these refer to essentially data being missing. So to get the null value, you just type out null. To get the undefined value, you type out undefined. And both of these refer to missing data. I'm not going to really go into the difference between the 2 right now, but just be aware that they both exist and they both kind of refer to nothingness. So that's it for you. Those are the 5 basic types I want to start you off with. Numbers, which are exactly what they sound like. Strings, which are a bit of text or characters or single letters. Booleans are true or false. And null and undefined are both created just using the keyword null or undefined. And they refer to a lack of data. Okay, so what in the world do we do with these data types now that we know what they are? Well, for starters, we can store them in variables. So let me go ahead and create a variable called, I will call this age. And we can set it equal to 32. Okay. So let's say that we wanted to keep track of someone's age. Well, we could just create a number called 32 on its own, but once this line is done being executed, we can't really use this number. It doesn't exist anywhere in memory. It's being created and then basically disappearing immediately afterwards. So that's why we store things in variables. So in this line, I've created a variable called age. I've stored the value of 32 in it. And now if I ever want to access that age, I can look it up using my variable name. So when I run this, notice that this last line of code, line 3, resolves over here in green to 32. That means that this value, this number, is being stored somewhere in memory, and we can access it using this variable name. So let me break down in detail this statement where I've created a variable and stored a value in it. Well, I start out with a keyword. And keywords are really important. We've kind of explored this idea already. They're basically these built-in words in our languages that allow us to do cool bits of logic. So the const keyword is built into JavaScript, and it's built in for the creation of variables. So whenever I use the keyword const, the code will expect a variable name afterwards. So age is something that I make up. I could call this whatever I wanted. As always, we want to call it something useful. And the main restriction is we can't use a keyword as a variable name. I couldn't say const. I'm now getting an error. But I just come up with some useful name that'll help me look up my value later. So this bit of code is actually creating a variable called age. Then I do a single equal sign, which denotes assignment. That means I want to store a value in here, and then I put the actual value I want to store. So whatever is over here on the right side of the equal sign is going to be one of these data types we've explored so far. So in this case, a string is being stored into age. And then I can use that variable to look up the age later. So that is one way of declaring a variable. And let me talk a little more about this const keyword. So const stands for constant. And it stands for constant because that means that whatever we put in, that is the value that's going to stay inside of age. So I might try to reassign age to something else, but I'm going to get an error. So whenever we declare a constant variable, and this line of code would be the variable declaration, whatever we store in the variable stays in the variable. Nothing else can be stored in age ever again, except for 32. So this might seem like an annoying restriction, but it's actually a really useful restriction because it turns out that it's good practice to keep a single variable in a variable. You don't want to be passing around variables and using them for a bunch of different things most of the time. That's how you end up with bugs in your code. So we actually really love the constant keyword. In almost every case, it's the keyword I am going to use to declare a variable. It's sort of this built-in restriction that almost forces us to write good code. But sometimes it's not right. For example, if we were writing a web app that was going to keep track of someone's age over time, then we would need to change the value because within the next year, whoever's age this is going to have a birthday. So that wouldn't work very well because if we tried to change age to 33, we would get an error. So in that case, we would want to use the let keyword. So the let keyword works almost exactly the same as const, except it allows us to change the value. There's one other cool thing that let does, but I'm not going to tell you about it just yet because we need a little more info on it. So preview of things to come, I'll tell you a little more cool stuff about let in a later lesson. But for right now, you can think of let as being, the difference between let and const as being that let allows us to change the value of a variable, whereas const forces us to keep it the same. So notice that if on line 2, I create a variable called age and I store a number into it. On line 3, I redefine what's in there. And notice that I don't have to use let again because the variable already exists. I just want to reassign it. So my syntax is slightly different when I'm reassigning. And then on line 4, I'm looking up what's in age. And we can see over here in green that the new value of 33 is stored in age. So those are our two different ways to define variables. Notice that I don't have to put a number in here. I could also put a string if I wanted this to be name. And then I look up what's in name, and I see that Harry Potter's name is stored in here. So yeah, we can put strings, we can put Booleans in variables, we can put null values. We can also, by default, by the way, if you declare a let variable. So notice that if you declare a variable using let, you don't actually have to put anything in it to start if you don't want. You might be like, all right, I'm going to declare this, but I'm going to use it later. And so if you look inside of this variable, notice that it's set to undefined by default. So here's a little example of where our friend undefined might pop up. If we create a variable but don't store anything in it, by default, it will contain the value of undefined. And that tells us as a coder, okay, no value has been put in here yet. If, for example, we were trying to create info for a homeless user and we had an address variable, we might want to explicitly say address is equal to null. If I look up address, I see that the null value is in it, and I might say, oh, this user probably doesn't have an address, or at least that data is missing. So just a couple examples of where these two weird data types called null and undefined might crop up. All right. So that is the basics of declaring variables. And so we've explored a few keywords in JavaScript, a few keywords in JavaScript, a little bit of the syntax, this idea of creating a variable, storing data in it, and then looking up that variable name later. So this variable idea is pretty key to programming, and it's really going to play into basically everything else we do. So if you're brand new to programming, don't worry if it takes you a minute to get used to this variable concept, but you're going to be doing a lot of this. So you'll get used to it super quickly, I promise. Okay, so let's check out some other cool things about these data types. Okay, so there's a reason that we like to differentiate data types. There is a reason, for example, that the number 32 is different than the string 32. One reason is math. So we have the ability to do math built into JavaScript. So if we want to, say, add things up, we can do that. If we want to subtract some numbers, we can do that. We can also divide them. And we can multiply them. So all of our basic math operations and some not so basic math operations are built into JavaScript. And those work with numbers. So something cool we can do is we don't actually have to work with numbers directly. So say I have two different numbers stored into these X and Y variables. As we know, we could look them up just to see what the values are, but that's not very interesting. We can also work with these. So if we wanted to add them together, we could add them up just using the variable name. And notice that this resolves to 9. So anything we could do with the values, we can also do with the variables that contain the values. And that is one of the super powerful pieces of JavaScript. A couple other fun things we can do is we can compare. This comparison would be greater than or equals to. And notice that when we compare these, the resolution of that line of code is actually a Boolean, true or false. So we'll look a lot more at comparisons at the end of the lesson and tomorrow because they play pretty critically into our last topic. Let's see, what else can we do? Oh yes, I want to show you one example of why strings and numbers are different. So check this out. So before X and Y were equal to numbers, now they're equal to strings. And remember, even though these strings contain numbers, they're still considered strings because we created them using quotes. So what happens if I do X plus Y? So notice that instead of getting the value 9, we get the string 36. That's because the plus operator does something different depending on if you're working with numbers or strings. When you do plus, when you add two numbers together, you get the mathematical value of adding them together. When you add two strings together, it just concatenates them or just slaps them together into a bigger string. So if I did hello and there and added those together, it would give us the full string of hello there. Notice that I did put in the space myself. So it is really useful to use this plus with the strings as well as the numbers. You just have to be clear about, what am I working with? Am I working with a string or a number? Or else some unexpected things might happen. All right, I want to show you a couple more mathy things that we can do, and then we will move on to a couple other topics. So a couple other operators we can work with are, let's do, oh, this is a good one. Let's do plus plus. Okay. So x plus plus will actually increment the value of x. So if I create this variable called x and store 9 in it, do the plus plus operator on it, and then look inside of it, this will be incremented to 10. So xx actually changes the value. So notice if I do x plus 4, this line of code would create the value 13. So let's walk through this one line by line. Line 2 actually creates a variable called x with 9 stored in it. Line 3 adds 9 to 4. But notice that we can't actually see the resolution of this because Replit just by default only shows us the last line. So we did add it together, but then notice that the value of x hasn't changed. So in this line, we used x, but we didn't change it. However, if we do this plus plus operator, we actually change the value of x. So when we look in it later, we see that it's been increased. There's also an operator called minus minus, and it will decrease the value of x. So this operator, it turns out, is super useful. We'll see one really great use case of the plus plus and minus minus operator in our lesson tomorrow. The final thing I want to point out with this operator is that notice that I use the keyword let. If I had used const, we would have gotten an error. That's because we're actually changing the value of x in this line. And that's not allowed if we have a constant variable. So whenever we're using the plus plus or minus operator, we have to use let. So if we went back to this age example, and age was increasing, we could do age plus plus whenever our user's birthday occurred, and then we would see that the value of age had increased by 1. And then maybe the next year we do age plus plus again, and now it's up to 11. So that's a cool little built-in operator that we can do on numbers. So this is a number-specific operator. Not going to work very well if we try to do it on a non-number. All right, what are some other things I want to show you? Oh yeah, I want to show you something called the mod operator. And if you're not familiar with the idea of math and remainders or modular arithmetic, this might seem a little weird at first. So let's do, so the mod operator is our percentage sign. So if we do 4 mod 2, we get 0. So the mod operator basically says, okay, take 4, divide it by 2, and give me the remainder. And because 2 goes into 4, the remainder is 0. But if I do 2 divided by 3, I have a remainder of 1. So that is the mod operator. I'm just kind of mentioning it as a note. Honestly, we won't really use it in this course, but it becomes surprisingly useful in a lot of circumstances, and it's a really important computer science-y thing to be able to use. So good for you guys to know. So that's the mod operator, another fun thing we can do with numbers. And then the last thing I want to show you is the not operator. So notice that all the operators we've been playing with are pretty much for numbers. We did see the example of combining strings. So it turns out the plus operator does work on strings. Here's an operator that we use on Booleans. It's called the not operator. So when we use the not operator on a Boolean, it turns that Boolean into its opposite. So if we do not true, we get false. If we do not false, we get true. And so I know I'm throwing a lot of stuff at you guys right now. I'm really just kind of building up your toolbox here. So all these things that we're exploring right now are things that are going to become incredibly useful as we look more and more into the language. So I know I'm just throwing a lot of weird concepts at you guys right now, but I promise as we go on for the rest of the week and next week, all of a sudden these little tools that I'm showing you now are going to become incredibly useful. So thanks for bearing with me with all these random operators. The biggest takeaway right now is this idea of we have to know which data type we're working with. Because if we try to mod strings together, for example, strange things would happen. I don't think I've ever tried to do that. So let's try that. You never know what JavaScript's going to do. So if we tried to use the mod operator, we just got not a number. So by default, if we try to do something number related with strings, we're probably going to end up with NaN, which stands for not a number. So we have to make sure that we're using our operators with the data type that it's expecting. Okay, so let's move on to another cool feature of some of our different data types, which are called properties and methods. So I'm going to create a string. Okay, so I've created this name string here. And then let's go ahead and check out this. So all strings have a property on them called length. And that tells us how many characters are within this. So including the space, it counts up all the letters in here, all the characters, and it will give us a number that represents how many characters are in here. So notice this is another example where we need to know what we're working with, because if we tried to do x.length, you would get undefined because numbers do not have length. But if this is actually a string, then we get a length of 1. So built into everything we have this, or every string, we have this length property. And to go over the syntax of that, whenever we're working with a property, we start with the variable name, followed by a dot, followed by the name of the property. And so properties are things that are built into the language. So we just have to know or have to look up what properties exist on strings, and any of those properties we could look up using dot notation. So we do the variable name, dot, the property name, and then that will resolve to the value. And if we want, we can always take this and store it in a new variable. So I could go ahead and access the property name, or access the value of the property, and then store that in a new variable. So far, we've pretty much just seen declaring variables based on actually explicitly writing out the value. But we could access something that contains the value and store that into a new variable. So now length is a variable that contains the value of 19, which we accessed by checking out the length property on this name. So that's a cool thing about JavaScript that can be a little tough at first, is this idea of we can pretty much, once we have a chunk of code that resolves to a value, we can use it in any way that we could use that regular value. So we could use this chunk of code exactly like we could use the number 19. We could do name.length plus 10, and that'll work exactly the same as if we just did 19 plus 10. We could divide, we could mod, we could do whatever we wanted. So this, even though this looks like a bit of text, this actually resolves to 19. So we could treat this like the number 19 in any context and be fine. So that's a little bit about properties. Built into these values, we also have things called methods. So methods are kind of like properties, except they're a little more advanced. So let me show you one example of a method. Okay, so we have a method called toUpperCase, and this is once again built in on every string. And what this does is it takes the value of our string and it uppercases it. Over here we have our name all in caps. So the notation or the syntax looks really similar to what we did with our property. We just started with a variable name, followed by a dot, followed by the actual by the name of the method, which is going to be built in. So these method names, we just kind of have to know them or have access to the documentation, which is actually up here. And then we follow it by a set of parentheses. So the reason that methods have parentheses and properties do not is that methods are actually something called functions. And we will look in great detail at functions on Monday. We'll see what they are, how they work, how to write them, how to use them. But for right now, all you have to know is that methods are something called a function. That's a totally different JavaScript data type that's a bit more advanced than these 5. These 5 are called primitive types, whereas functions are a little more complex. But in order to use them, we have to follow them with parentheses. So if we just do name dot to uppercase, this is a function. So this is like the capacity. This is like a rule book for creating uppercase letters. But when we follow it by the parentheses, we've now executed the function, which means that this will resolve to the result of running this logic. So with the parentheses on our method, we can go ahead and actually see this uppercased version of our name. So that is our first example of methods. Once again, methods are these cool built-in bits of logic on different data types that allow us to do fun things. Another thing we could do on a number, let's create a number here, is if we did x.toString, and toString is a method that's built in on everything. So if we do x.toString, notice that it takes our number 9 and it creates the string 9. So we can do that with a Boolean as well. So if we did a variable called learning JavaScript, set it equal to true, and then down here we ran learning JavaScript.toString, it would go ahead and take this Boolean and stringify it. So there are a bunch of these cool built-in methods. Over here, we can see a bajillion string methods. There are a bunch. So if you are feeling daring, you can go and check those out. But just wanted to remind you guys that we love documentation and Googling things is a great way to go. And a reminder, I know I've said this a bunch already with HTML and CSS, but you guys do not have to memorize all the ins and outs of these languages you're learning. I would be extremely impressed if anyone were to memorize all the ins and outs of any of these languages. You want to learn the basics and then use the documentation at your leisure to save brain space, because why memorize something that we can look up super easily? That's my excuse for being bad at memorizing things. Okay, so those are methods for you. They're these built-in bits of logic that we can execute using parentheses. All right, so now let's try, let's look at a couple of other cool built-in methods. So I'm actually going to wipe this. So notice that all the variables that we've used so far are things that we've actually created. Like if we create a name variable, we can access it. But it turns out that there are a few variables that already exist. They're called global objects. They're things that are built in that we can use from the get-go. So one is this thing called math. Another one is called a console. So the console is a little complicated, so don't worry too much about what appeared in green over here. But notice that these are not keywords per se. They're global objects, which means that they're actual objects that exist in JavaScript already. And these things are great because they have built-in methods on them. So let's start with math. Math has a bunch of cool built-in methods on it. One example is the absolute value function. So math.abs will give us the absolute value of a number. And so notice that this method, unlike the other two we've seen, actually has a bit of input. We would call that an argument. So these parentheses aren't totally there for show. We can actually put values in them, and we're expected to put values in them in some cases. So the absolute value function expects one number to be put in the parentheses, and then it will give us the absolute value of that number. Another math function is math.pow. That stands for power. Math.pow expects two arguments, 2 bits of data to be put in. the base and the exponent. So math.pow is going to take 2 to the power of 3 in this case. Or we could do 6 to the power of 2 if we wanted. Or 6 to the power of -1 if we wanted. So we have a way of doing exponents. And notice that a little reminder of why JavaScript is cool. Instead of actually putting numbers directly in, if we wanted to, we could put variables that represent numbers, and it will still work exactly the same. So that is another math method that we might want to use. Okay, let's see. I want to also show you the round method. So we can do math.round. Oops, round. And if we put in a decimal, it will round that decimal. So we could do 3.2, that'll round down. Another couple rounding options we have are math.floor. Math.floor rounds down every time. So even if it's 3.999, still will round down. Its counterpart is math.ceil, which will round up every time. So I know I'm breezing through these pretty quickly, just kind of exposing you to some of the cool stuff out here. You will have to use some of these for the homework though. So if you're like, oh no, I can't remember exactly what the syntax is for that function that rounds down every time or rounds up, just Google and you'll be able to find all this documentation on the math methods that are built in. One more math method I want to show you. And this one does not take in any arguments. That means there's no input. So this is called math.random. And every time we run this, it gives us a new random number in between 0 and 1. So really nice to have this randomizer built in whenever we want to randomize something. So that is math.random for you. So these are all methods that are built into our global object of math. The next global object I want to show you is the console. And the console has this really useful function called console log. So before I show you how to use console log, let me tell you all about the console. All right, so we have something called the console built into all of our web pages. So remember how we inspected elements the first night and saw that cool little inspector thing on the side? It turns out that built into this sidebar is something called the console. By the way, I opened that using Option Command J on my Mac, and I should memorize that for the PC, for all you PC users, but sorry, I don't know what the shortcut is. You can also just go to Inspect like you did before and click on the Console tab. That's another way to get to the console. So the console is this cool little world in JavaScript access into what's going on in the web page. So we can give ourselves feedback using the console. It's a really great debugging tool. So if I go back to my code base, here's my JavaScript, which maybe looks slightly less arcane to you guys now. And I wrote console.log and then put a message. When I open this web page, this message will appear over here in the console. So that's really useful for debugging because you might be like, why is my code broken? And you can console log things in real time in order to see what they're equal to. Right now, this just shows me this little hey guys. And I know this is tiny for you guys, but over here, I got a little message in the console. So it's cool. Check out the console on web pages. Just the other day, I was looking at, oh gosh, I can't remember. I think it was on the Guardian's website. And in the console was this little message about, hey, we're hiring. Any web developers should apply here. So sometimes you'll find weird, fun stuff over here in the console. Sometimes you'll find errors. It's cool to just look in the console and see what pops up. As far as how we'll use the console is a nice way in Replit to see what's going on. So notice if I do and then I did x plus y, and then x minus y, and ran the code, I only get to see this last line of code, right? Because by default, Replit will only show you the last line of code in green. But what if I wanted to see what was going on here? Well, I could go ahead and plug x plus y into my console log, and whatever this code resolves to will appear over here. Anything that is logged to the console appears in white in Replit. So that's just a design choice on Replit's side to keep things clear. So I will remind you like 8 more times, but green in Replit is our last line of code. White in Replit is our console log. So I can console log whatever I want in Replit. And it will appear over here in white. I can console log like 8 things. I'm not going to type out 8. But we'll do 2. Another cool thing is I can actually pass different values into Replit. I can pass in as many arguments as I want. Remember, arguments are just values that we pass into a method. And it will log all of them. So that's pretty cool. Console, super useful tool for debugging. We'll use it throughout the course. It's a great way to get an idea of what's going on. If you write a bunch of lines of code and you want to double check that a variable is equal to what you think it is, just throw it in a console log and you'll be able to see it over here in white. And as a reminder, console log is another example of a method. So the console is a global object. It's an object that's built into JavaScript, and it has this cool method called log on it. And when we call it and pass a value in, it will appear over here in white in Replit, and in a real code base, it would appear over here in the actual console. So that is the console for you guys, and my last example of a method. Okay, so there's one more thing I want to teach you guys tonight. I see that there are some good questions being asked in Slack. I will get to them at the end. But the last thing I want to talk to you about is this idea of control flow. So notice that when I create variables, wait, what am I doing? Okay, x equals 3, y equals 2, y. So when I run this bit of code, it more or less is going to run in order. We'll start out at the top with creating x and assigning 3 in it. Then we'll create y and assign 2 in it. And then we will add them together. Notice that if I put this at the top, we're going to have some problems. We get not a number because these values have not been stored inside of x and y yet. So for the most part, we can think of JavaScript as basically just running in order. And as it were, every line of code is going to run too. So we run in order and we run every line of code once. That is kind of the default of JavaScript. But that's pretty limiting because sometimes we might want our code to be a little more dynamic. We might want bits of lines of code to be skipped under some conditions, or other lines of code to be run multiple times under different conditions. And that is where control flow comes into play. Control flow is where we, the developer, affect the flow of code. And what that means is that we might be changing which lines of code are run, which order they're run in, or making different lines of code run multiple times. So control flow is a pretty interesting topic, and we're actually going to spend all of tomorrow talking about it. But I want to introduce you to one bit of it tonight so that you can do some fun stuff on the homework and that you can feel like you have a foundation for tomorrow. And so what I'm going to introduce you to is the if statement. So here is an if statement. So what I'm saying is, if a condition is true, run this line of code. So it turns out that line 4 is optional. In some cases, it's going to run, but in other cases, we might skip it. So notice that my console log never ran. So let's look at the syntax of the if statement. We start off with a keyword called if. After that, we put in parentheses, and inside here, we have some sort of condition. Like, for example, it might be if 2 is less than 3. And then we follow the condition by these curly brackets. Inside the curly brackets is something called the if scope. We'll talk more about that a bit tomorrow. So this is the if scope, or the if block. Inside of our if block, we have whatever optional bit of code we want to run. So everything inside of here, it could be 1 line of code, it could be 30 lines of code, it could be 100 lines of code. All of that will only run if the condition is met. So right now it's going to run because 2, in fact, is less than 3. But if I change this to -1, now it's false. So whatever we put in here should be some sort of Boolean value. As I showed you at the beginning, we could actually directly put in true or false, which isn't very interesting because we've hard-coded it to either run or not run. We could put in some sort of value that resolves to a Boolean, like a comparison. Or we could do this. We could create a variable called condition or whatever we want to call it. Did I spell condition right? Yes. And then we can just plop that variable name in. And remember that wherever we could use a Boolean, we could also use a variable set equal to a Boolean. So now maybe this condition changes based on user input or what time of day it is or what the weather is like or whatever. And sometimes this runs and sometimes it doesn't. So sometimes we want kind of an alternate, right? Right now, if the condition is set to false, we skip the if block and that's the end of the story. But we might want a backup option. That's where we use the keyword else. So we do the keyword else followed by another set of curly brackets. Now we're in the else block. So the else block is kind of our alternative option. So now when the condition is false, we skip the if and run the else instead. So we can have an if by itself or we can have an if else together. So an if else is a way to set up, we have a one option or another. There's no way that both lines of code would ever run. Some of the times line 6 would run, some of the time line 9 would run. It would always be one or the other, but it would never be both. So that is an if else statement. So if we did, for example, raining, which we will set to true because I am in Seattle and I can in fact see the rain falling out the window right now. So maybe if it is raining, we might say, let's watch a movie. And if it is not raining, we might say, let's go to the park. And so because it's raining right now, the if statement is run and we get this console log that says, let's watch a movie. But when I get back to Bisbee, where it is the desert and it will almost certainly not be raining, though actually it's supposed to rain there this weekend, but that's totally unrelated to coding. Then we do raining equals false. And now the code says, let's go to the park. So we can use these if-else statements to run different meaningful bits of code based on some sort of external circumstances. And maybe this is a bit more advanced, but maybe instead of just hard coding this raining value, we're actually requesting data from a weather database and getting real live values about if it's raining or not. So that's a little more advanced than what we'll learn in the mini boot camp, but you'll learn all about APIs in the main curriculum, which is a way that we could actually access some sort of external bit of data and create something that live updates what's logged based on if it's actually raining or not. So anyways, that is an if-else statement, a little introduction to control flow, which we will explore a ton of tomorrow. And that is all I want to teach you guys tonight in JavaScript. So let me go ahead and open up the floor to questions. I'll try and go back and see which questions I've missed throughout the evening. I'll get to as many as I can, but yeah. Okay, let's see what we've got. Okay, so there's a bit of talk about incrementing in here. So let me go over a couple different ways to increment. All right, so I showed you guys this way of incrementing x. So if we do x ++ and then look inside of x, we will see that it is now equal to 9 because I've incremented it. Well, what if we want to not increment it by 1, but increment it by 2? There are a couple options we have. We can actually change what's inside of it. So this is a pretty cool thing we can do that looks a little weird when we're not used to it. which is we can actually say, okay, take the current value of x, add 2 to it, so that's going to give us 10, and then store that value in x. So we're actually using the old value of x, adding 2, and then redefining what x is equal to. So in this way, we could add whatever we wanted to it. But it turns out that this bit of logic is pretty common, so there's a shortcut. So I'll comment this out and show you another way of doing that. So there's an operator which is plus equals, and what I'm saying is take the current value of x, add 10, and save it back into x. So this line of code does the same thing as this line of code. It's just a little shortcut. I could also do minus equals. So you don't need to know these operators, but it's nice to know, but they are nice to know, and they could be really useful, especially once we get to loops, which will happen tomorrow. So there's a little bit about incrementing. And notice that this only works because I used let. If I try to use these operators with const, I'm going to get an error because we're trying to redefine what x is, and that won't work if x is constant. So let. Okay, let's see what else we got here. Okay, we have a couple questions about, I'm going to start with this question about the not operator. So we have, so there's this question of what's the point of doing the not operator if we already have true and false built in for us? Well, I'll partially not answer this and say that tomorrow you're going to see some really cool uses of the not operator. But let me show an example where the not operator would be useful. So let's say we have this variable called raining, and it's equal to true. So we could do if raining and then do something. But let's say we wanted an if statement that only happens if it's not raining. We could say, okay, if not raining, then so here's just a little example of where it would be nice to use the not, because we can use the not to say, okay, I want this if statement to run if this thing is not true. So then if it's not raining, let's go for a walk, we'll run. Okay, we had a little question also about typing. So in this console, you can actually just start writing JavaScript. So it's kind of like its own little REPL in here. So I can start creating variables, la la la. And if I do a console log in a console, it will appear because all this code is run. So if you want a little shortcut to just writing code right in the browser, you can always go into the console. All right, let's see what else we have. Okay, cool. Sorry, we're kind of going all over the map with the questions here. So a question about math.random. So someone tried to pass in some values and probably noticed that it runs exactly the same. So this is a weird thing about JavaScript, is that so every method or function expects value, expects a certain amount of values. The random method expects 0 values. But it turns out that if you just pass random values in, it won't throw an error. It will just ignore them. So if you ever pass in extra values or pass values into a method that doesn't expect them, they just ignore them. So if we did math.round and we did, 2.5 and then threw in a bunch of extras, it would ignore all of these other arguments. So it's because round expects 1, it will only look at the first. And then we have weird functions like console log, which don't expect a set amount. You can put in however many you want. So however many arguments you want, you can put into console log, and it will use all of them. But most methods are going to expect a certain amount and they'll just ignore the rest if you put them in. So you can if you want, but there's no point. Okay, let's we have someone asking about proto. So I'm not sure where you saw proto. One example might be in this documentation. There's this word prototype listed a bajillion times with all these methods. Prototype is awesome. It's a little complicated, so we're not going to talk about it tonight. We will talk about it next week, though. So sorry to skip the question, but for right now, don't worry about prototype. We want to do some ramping up before we can really understand it, but something to look forward to next week is we will learn all about the prototype. Okay, we have a little bit of a question about how console log is useful for debugging. So let's say that I did string 1 equals hello, string 2 equals world, and then I did string 3 is equal to hello world. So we'll do string 1 plus string 2. So we think that string 3 is going to be equal to hello world, right? Okay. And then now we want to do string 3 dot length. So I run this and I see 10. But if I count the characters, I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this would be a moment where we're like, uh-oh, my code has a bug in it, because I was expecting string 3 to have a length of 11, but instead it has a length of 10. So I might want to do, okay, console.log equals string 3, and now I can see, oh, it's missing a space. And then I understand why my code isn't working. So a lot of the times you'll have a big chunk of code and you're trying to figure out at what point did this code stop doing what I'm expecting it to do. And you can use console logs to get an idea of what's going on. There's also some really awesome debugging tools that are way more sophisticated than that built into the browser. But for what you're working on, console logs would be a good place to start if you're wanting to try and debug something. So hopefully that gives you a little bit of an insight into why console logs would help with debugging. All right, question about using, I'm gonna wrap up the questions in a second. I love how interactive you guys are, but I wanna make sure you have time for homework. So I'll just answer 1 or 2 more. This question, there's one question about how do you use random to get a random integer? Okay, so it's gonna give me a random number between 0 and 1. But what if I want a random number between, let's say, random number between 0 and 5, and not just a number, but a random integer, so a whole number between 0 and 5. Here's what you would do. So you would actually do math.random. So there are 6 options. It could be 0, actually, sorry, let's do 1 to 5. Okay, so here we have 5 options. So what we could do is we could do math.random times 5. So notice that now it truly is a random number between 0 and 5, but we still want whole numbers. So let's plop this whole thing in math.ceil. Remember, ceil rounds up. And voila. Now we have a random integer between 1 and 5. So a lot of the times you'll see something that looks like this or something that looks like this. This is a really common bit of code that you'll see a lot when you actually want a random whole number. So that's how you do that. And a little example of how you can plop methods within methods. Remember, this resolves to a number, so we could use this like we could use any other number and actually throw that into another method call. Okay, one kind of random question about the main curriculum about learning React Native or React.js. So I just want to mention this because I think frameworks are great and I always look for an excuse to talk about frameworks. So JavaScript is an awesome web development tool. But there are these things called frameworks. So some JavaScript frameworks are React. There's one called Angular. There's one called Mithril that no one's heard of, but it's really cool, so I'm going to rep it right now. My coding instructor actually in code school was obsessed with Mithril. It's really cool. Check it out. But the documentation is kind of terrible. Anyways, so these are all layers that we put on top of JavaScript to make it even more powerful for making web apps and websites. So these are really great. They're a core part of what happens in the coding industry. And in our course, in the main curriculum, we will be learning React. So not in this mini boot camp, unfortunately, because we're just going to be learning the basics of JavaScript. But in the actual main Lambda curriculum, you will learn React, which is a super cool tool. It's one of my favorites. Yeah, so that's a little bit about, little reminder of what you'll learn in the main curriculum, and just a little shout out to frameworks, which are really cool. So you should be excited to get all this basic stuff down, because then you can do fun things with frameworks. All right, so I am going to call it for tonight, because I want you guys to have plenty of opportunity to work on the homework. And unfortunately, I forgot to pull up the homework in advance to show you guys what it looks like for tonight. So I apologize for that, but it will be in, you will be receiving the homework in Replit. So from here on out, all of the homework will be happening in Replit. So that will be sent out via your homework groups as usual. You'll have an opportunity to practice reading code and to practice writing code. So kind of similar to what you've seen so far, a couple different approaches that you'll work with. So as always, keep asking questions in Slack, work with your group, reach out if you're totally stuck, but first, Google. Always Google first. And that's pretty much all I've got for you guys tonight. So thank you for being a great class as always, and have fun with the homework tonight. All right, well, that's all I've got for you guys. So yeah, tonight was the first night of JavaScript. I'm really excited to be diving into this. I personally love JavaScript because whereas, I mean, HTML and CSS are really cool tools that can get complex, but they're really limited in what you can actually do with them. Whereas with JavaScript, once you have a few basic rules down, all of a sudden you can build just about everything. So I'm really excited to share that with you guys. And tomorrow we'll get into more things with conditionals and control flow. And then next week we'll see all sorts of fun stuff. So I will see you guys tomorrow, and good luck with the homework. Have a great night.